Alrighty, and lastly from section 4.10, we did a lot of writing quadratic functions and quadratic models based on the information given. So in problem number 45, we are given our x-intercepts. Well, if that's the case, we should probably write it in intercept form. So let's remind ourselves that intercept form is y equals a times x minus p, x minus q, where p and q are the intercepts. So if I have negative 3 and positive 2, I have y equals a, or times x minus negative 3, which turns into x plus 3, times x minus 2. And then from here, we want to plug in that ordered pair for x and y and swap out each of those values for our x and our y. So we'll have 12 equals a times 3 minus negative 3 times 3 minus 2. So that this way we can solve for a. So as I'm solving for a, I have 12 equals a times 6 times 1. So that means that 12 equals 6a, so a must be 2. So lastly, I replace a, p, and q in my final equation. So y equals 2 times x plus 3, x minus 2. In problem number 46, they gave me 3 ordered pairs. So that means that I want to write this guy in standard form, which is y equals ax squared plus bx plus c. And I plug in each of these ordered pairs individually to see what happens. So plugging in my first ordered pair, I have 2 equals a times x squared. Well, that would be 25a. Plus b times x, well, that would be 5b. Plus c. Plugging in my second ordered pair, I have 2 equals, 0a, 0b, and then c. Oh, good. That means that 2 is c. Lastly, plugging in my last ordered pair, negative 6 equals 64a plus 8b plus c. Now from here, the first thing we want to do is recognize that we were given a value. That is amazing. So 2 is c. So from the very get-go, I'm going to replace both of those with plus 2, since they were both our c values. Well, if that's the case, that means I only have 2 equations with 2 unknowns, a and b. So in my first equation, my purple one it looks like, I'm going to go ahead and subtract 2 from both sides. So I have 0 equals 25a plus 5b. And for my second equation, again, subtract 2 from both sides. Negative 8 equals 64a plus 8b. Excuse me. I would go ahead and solve for that using elimination, because why not? I would multiply my first equation by negative 8, my second one by positive 5. So multiplying my first equation by negative 8, I have 0 equals negative 200a minus 40b. And then my second equation becomes negative 40 equals, 64 times 5. 6 times 5 is 32. 320a. How exciting. Plus 40b. Now this is good news because our b's cancel. So I have negative 40 equals 120a. When we divide both sides by 120, we find, zeros cancel, negative 1/3. Oh, good. Fractions. So a equals negative 1/3. We now know 2 of our variables. We have c from the get-go and a from just now. So we'll plug both of those values in from into one of our original equations to solve for b. So let's do our original purple. 2 equals 25 times negative 1/3. Fantastic. Plus 5b plus 2. Excuse me. So 25 times negative 1/3. I'm going to bet we're going to call that negative 25/3. Plus 5b plus 2, subtracting 2 from both sides, we have 0 equals negative 25 over 3 plus 5b. We are going to add 25 thirds to both sides, so 25 over 3 equals 5b. And to solve for b, we are going to multiply both sides by 1/5, which is great because that cancels slightly. So b is a positive 5 thirds. Now that we know what a, b, and c are, we get to throw those values back into y equals ax squared plus bx plus c. So our final answer is y equals ax squared, but instead of a, we have negative 1/3 x squared plus bx, but instead of b, we have positive 5/3 x plus, whoopsies, 2, again from the very beginning. For our last two problems, number 47 and 48, we are given the vertex for both, so we are going to want to write those in the vertex form, which is y equals a times x minus h squared plus k, where your vertex is hk, and you use your point to plug it in, rearrange, and solve for a. So we have 2 equals a times x minus h squared plus k. Then we start to simplify, so 4 minus 2 is 2, 2 squared is 4. So 2 equals 4a plus 7. Subtract 7 from both sides, negative 5 equals 4a, which means a must be negative 5/4. So as we go ahead and plug that back in, we have y equals negative 5/4 times x minus 2 squared plus 7. And with number 48, they tell us that we have a soccer ball that travels along this distance and goes through the point 0, 0, and has a vertex of 12, 7. So we are going to do the exact same thing for this one, actually. We have y equals a times x minus h squared plus k. The nice thing is that our ordered pair is 0, 0, so that will be pretty easy to plug in. So we've got 0 equals a times 0 minus 12 squared plus 7. 0 minus 12 would be negative 12. Negative 12 quantity squared is a positive 144. And then subtract 7 from both sides. Negative 7 equals 144a. Divide both sides by 144. A must be negative 7 over 144. So we write that in our equation. Y equals negative 7 over 144 times x minus 12 squared plus 7.